All right, let us see some more details of working with dates. Let's take an example of purchase date. So where is that purchase date? That must be in orders data set. This is order purchase date timestamp. It is given as yearly. We know how to modify it. Quarterly, monthly, daily. That is one way. Or you can click on this. This is aggregated by every quarter. This is aggregated by every year, like that. Let's bring it back, bring it back, bring it back. Okay. Let's remove. Or if you want to just keep quarter, that is also fine. Or simply click on this order purchase timestamp. Click on this, and then this is aggregated. Okay. Aggregated by every month. That means even if you have 4 years, only these months will be appearing. Let me explain you that. Let me show you the purchase amount. So in the payments, you will have payment value. This is the total sales on a given month. Let's create a chart. Okay. Now the sales payment value, let me put it as label. These are the labels. What I'm trying to say is this month, though you have multiple years, though you have 2016, 2017, 2018 data. So you should have all the months from 2016, 2017, 2018. But when you say month here, it is 2016, 17, 18. All those 3 months aggregated, all those 3 months aggregated, all the 3 years aggregated. If you really want month-wise data, you have to choose this option, May 2015. It's like that. This is first 2016, followed by 2017, then followed by 2018. If you still want to make it look somewhat attractive, you can put it on color, or you can put it on size also. That looks somewhat like this, where there is higher sales, you're trying to highlight that. Lower sales, you're almost trying to suppress it. You can edit the color also. But the point that we are trying to show is anyway displayed here. This is monthly sales. This is monthly sales. Okay. That's how you work with the dates. That is the here you can keep it like aggregated data, all the months in all years, or you can keep it like a time series data. Usually time series data is the one that most of the in applications you will find. If you're showing monthly aggregated data, try not to show a trend chart like this. Try to use a bar chart. That's a better visualization. This is, if you use this option, it will simply swap rows and columns. This is aggregated data month wise. So this is better. Okay. So in January, in all the years, how much, in February, in all the years, how much, then you can also keep it as the color also. Okay, different colors. This one, this is too much. We can just leave it that day. Okay. If you want to find the date difference, let us suppose you have order purchase date, you have order delivery. From purchase to delivery, let's call that as time for delivery time. Okay, so let's create that variable. So from here you create a calculated field, there are other options as well, group, set, and all that. Will come to that. So this is time for delivery, time for delivery. What is time for delivery? Order delivery date. So you have to come here and write down order delivery date, order estimated delivery, order delivered to customer. This one, order delivered to customer date minus the display is somewhat not looking good here, but I'm trying to write down order purchase date, order purchase timestamp. Okay. So order delivery date minus order purchase timestamp. Automatically what it will do is it will find out the number of days for time for delivery. So if you want to analyze that data, time for delivery, so let us see how do you find out like day wise, or what is the time for delivery. Okay, overall, if you want to analyze that data, this is the overall sum time for delivery. Okay, so let us see order delivery date and order purchase date just to see whether this formula is working or not. What I'll do is I will take order delivery date. I will also take order purchase timestamp. Okay, and then time for delivery is what I'll take. Let's keep it here and let me put that on label. And this one, instead of year, make it like day, actual day. This one also, instead of year, keep it like actual day. And these are the ones, and I'll try to make it tabular. Okay, again I have to put it like this. Now you can see that 15 September to 4th October, 55 days. And then let us go for a smaller value. Let's sort this. Let us see some numbers. Where are these numbers? 55 days is here, or maybe let's take a transpose of it and then let's sort it, or let me sort it by this one. Still the numbers are, yeah. So if you come here, like try to scroll this way, these are 9 days: 20th October, 30th September. Order purchase date is 30 September, and then order, this is 30 September. Order delivery date is day of order. This is estimated delivery. No, I don't want estimated delivery. Customer delivery date. Yes. And then I want to take the day of that. Yeah. So if you take the day of that and then make it into a table and then bring it here. Now, if you scroll it this way, or first let us try to sort it after scrolling it. Maybe a little down. Yeah, here I'm finding some numbers. Try to scroll to a place where you can find some numbers. So day of the delivery, and this is the order purchase date. 7th October is purchased, and day of the delivery is, this is 7th October. What is this? This is the order delivery, order purchase. Yeah, correct. Order deliver date, order purchase date. What is it? It is showing it as 63. Is it due to time instead of time? Summation measure, it has to be as it is. Okay, yeah, looks like there is something wrong here. Let us see, we will be able to resolve it. Once again, let us see the formula then. Time for delivery, edit, order delivered to customer, that date, minus order purchase timestamp. Yes, that's correct. That's perfectly fine. Once again, order delivered to customer on 15th October 2016. Order purchased on 8 October 2016. Why it is showing it as 70? Let us take customer ID or order ID as the detail. I think without that, it may not show us the right values. Or is this day correctly given? This day is also fine, and this day is also fine. Okay. Let us take that order ID and put it on detail. Maybe it is summing up several orders. Okay. That's why it is showing like that. 3rd October to 14th October. What happened earlier was, if there were 3 or 4 orders, it was just taking the sum of all of them. Okay. But here we don't want summation of all of them. In fact, even without order ID, let us say, is it possible to directly take time for delivery and keep it on text? Again, it is directly taking it as time. It is somehow converting it as measure. Shall we take it as attribute? No, this is not working. So what we will do is we will take order ID and try to put it on detail so that all the order IDs, all the members will be shown. Now check this out. The 76 will change right now. Now if you see this, 14th October is the delivery, 3rd October is the purchase. You purchased on 3rd October, 14th, 10.7 days. Okay, which makes sense. 4.5 days. 14th 9th October to 14th October, 4.5 days, 7.6 days. All these now really make sense, isn't it? All these values. So this is the order delivery, and there were some times where the delivery took place nearly 32 days or 30 days, almost 1 month. 8th October ordered and 8 November delivered, 32 days. 8 October, 9th November delivered. So it is taking a lot of time to delivery. What we can do is, instead of showing it in days, if we want to show it in months or in some other option, what we have to do is, instead of using that minus option, let us edit this formula. We can use a actual formula called date diff, date difference, date diff. And in which measure you want? Do you want the date difference in months or years or dates? You write it as months. I want it in months. Okay, date difference in months. Okay, comma. Actually, this display is somewhat, not showing correctly. So date diff, date diff. And, sometimes this is a small bug in Tableau, but there is nothing wrong in this month. And what is your initial date? So you can look at this here, date diff. This is a function. You start date, end date, start of the week. Start date for me. What is the start date? The start date is order purchase timestamp, isn't it? Order purchase timestamp, purchase timestamp. That is the start date. The end date is order customer delivery date, order delivered to the customer. And start of the week, you have to give something like start of the week. Simply you can say my Sunday is the start of the week. Okay, that's the start of the week. You can simply use the same option, s lowercase. Okay, and then close this function. So the calculation contains errors. Let us see. Order purchase timestamp followed by order delivery to the customer. So once this everything is fine, then the calculation is valid for me. Okay. You will not be able to see the calculation cleanly. Now it is coming cleanly. Date, diff, month. Let me arrange it slightly looking better. Order purchase timestamp. That is the first parameter. The second parameter is order delivered. That's the end date. And the week starts on Sunday or Monday. Anything you can give. You simply put it as Sunday. It's okay. Now time for delivery, this is in months actually. Now 0 months, 1 month, 1 month, because I want to identify all those places where the delivery, all those orders that are taking more than a month for delivery. If there's a serious issue, I want to identify that. So let me identify those order. How many orders took more than a month for delivery? Let me take order ID and put it here. Use all members. How many order IDs have taken more than a month? In fact, I don't even need order ID. I'll simply take time for delivery and try to create a histogram for that, isn't it? Histogram would be sufficient. So there was time, and then what we will do is this histogram bin, we will try to make it as 0.5. We will edit it, make it as 0.5 as the bin size. Edit this. My bin size is 0.5, half month. Okay. Look at this. There are some orders that took half a month. There are some orders that took 1 month. There are some orders that took 2 months also, 3 months also. There are some orders that have taken a lot of time. Even 3 months also, there are some orders that took time. In fact, if you put it on label, you can see 95 orders took 3 months time. 23 orders took 4 months time. There is one order. There are 13 orders that took 5 months time. There are, 17 orders that took this one, like 34,949 orders took nearly 1 month time. Okay. If you want to look at the percentage, not really the values, if you want to see the seriousness of it, then you can look at the percentage, quick table calculation, and then the percent of total. 62% of the orders delivered on time, like within a month. I don't know whether it is on time. 36% of the orders took 1 month. 1% of the orders took more than 1 month. It is like 2 months time. Okay. We have already seen how to handle geolocation variables. We have seen when you have a data set, something like sellers data, if you go here. Now, if you have seller's zip code, if I want to create a graph using zip code, everything is given as unknown. This is an important information. Look at this, all of you. When you're working with geolocation variables, we are done with the previous one, by the way. We are done with this date difference function. Now we are coming back to this geolocation. In geolocation, very often you see unknown. That means this zip code is a geographical variable. This globe is shown, but these are coming as unknown. That means not understood by the Tableau. That means the region need to be adjusted. Edit locations. Right now, these zip codes, it is searching in my country, India. Otherwise, sometimes it will be showing in your country, US or some other countries. Okay. What we need to do is we have to select that country as, you know what, it's not India, it has to be Brazil. You have to search in Brazil. Okay. And then from the field, the geographic role also can be set. So once you're changing that to Brazil, now more than 2000 are unknown. Now looks like there are 38 issues zip code. Some of them are unrecognized. Some of them are recognized in Brazil. Now look at this. All these are recognized. So as of now, let us leave those unrecognized. Previously, 2000 are unknown locations. Now 38 are unknown locations. As of now, let us ignore those 38. Otherwise, you can click here, edit locations. You can map them, what this zip code is. As of now, I'm ignoring them. Okay. Now, once your zip code is identified, you can do any analysis. Let's say customers, or how many customers are there in each zip code, or how many sellers are there in each zip code. If you want to find it out, you can always find out. Let us see how many customers are there in each zip code. Okay. Customer ID is what I want to take. Count of customer IDs. Let's not double click it. It is going to create several of these graphs. What we will do is we will take that and put it on label customer ID, and that customer ID should be the count of customer IDs. These are all the customers from different places. The same thing can be put on color to highlight where are the most of the customers. The same thing can be put on size to even further highlight where the most of the customers are. Now you don't really need this one. Okay. And whenever you are working with colors, make sure that those are vibrant colors that everybody can see. Most of the customers are from this region, central region. Okay. That brings us to the second lab exercise for this session. I want you to work with dates and geolocation. Create a map chart to show the customer location and purchase value, some of the payment. So you have to draw that Brazil graph. On that Brazil graph, you have to show all the customer locations and purchase value. Where is the higher purchase? Maybe on the color or the size or both of them. You may want to show every customer and their purchase value. That is question number one. Question number two is use a function. Try to extract weekday, Sunday, Saturday, Monday, like weekday. Let's say if it is 25th November 2022. What day is it? Maybe is it a Sunday or a Monday or Tuesday? So you have 7 days, right? 1, 2, 3, 4, 5, 7. And then what is the average sales on every day? So I just want to find out whether the day does it really impact the sales. Looks like it is not. On day 1 as well as day 7, the sales is almost same. So which day it is not really impacting. But I want you to create a graph like this. For creating a graph like that, you have to first extract the weekday by writing a calculated field. So go ahead, write the calculated field, extract the weekday like this. That is your second exercise. Once you're done with this, then we will move on to the next topic of discussion.